all of you. How are you? Nice. Today we are going to discuss about some numerical problems based on the Kepler's law. All of you know that Kepler had given three laws. According to the third law of Kepler, T square variances R cube, okay, where T is the time period and R is the distance from the one body or one planet to the sun, okay. This can also written as T square upon R cube is equal to K, and T1 square upon R1 cube is equal to T2 square upon R2 cube, okay. It can be also written as T1 upon T2 to the power whole square and R1 upon R2 to the power cube, okay. It can also be written as T1 upon T2 is equal to R1 upon R2 to the power 3 upon 2, okay. This is the equation 1, okay. According to the question, T1 is equal to 1 year, okay. How many time takes our earth to complete one revolution of the earth? Speak out. Yeah, 1 year, okay. That means, and R2 is equal to 4 into R1. According to the question, your question, the average distance from the sun of a planet is 4 times in comparison to its distance from the earth. If R1 is the distance from the earth to the sun, then R2 will be equal to the 4 into R1, where R2 is the distance between the given planet to the sun, okay. In equation first, we put the value from 1 we have, okay. T1 upon T2 is equal to R1 upon 4R1 to the power 3 by 2. It can be also written as 1 by T2 is equal to this R1 cancel to this R1. That implies 1 upon 4 to the power 3 by 2. The value of T1 is 1 year here according to the question. It can be also written as 1 by T2 is equal to 1 by 2 square to the power 3 by 2, and this is cancelled to this and hence 1 by T2 is equal to 1 upon 8, that implies T2 is equal to 8 years after solving it, okay. And hence the time taken by the planet to complete one revolution is 8 years. This is our answer. Okay. Another one is, if the distance of the earth from the sun were half the present value, how many days would have been in 1 year? Here, question said, if the distance between earth and sun is reduced to its half, then how many days forms 1 year? Okay. Here solution is given. T1 is equal to 365 days. How many days is is in 1 year? Yeah, 365 days. Okay. R1 is the distance from the earth and the sun. Distance from the earth and the sun. Okay. R2 is equal to R1 by 2 according to the question. Okay. We have to find T2 is equal to what? That means how many days for 1 year. Okay. From Kepler's law we know that T, since T square varies R cube, it can be also written as T1 upon T2 is equal to R1 upon R2 to the power 3 by 2. All of you familiar from it. In previous question we explained here. Okay. According to question, T1 is equal to 365. We have to find the value of T2. R1 is equal to R1, but R2 is equal to R1 upon 2. Okay. And the power is 3 upon 2. How many power its raised? 3 upon 2. This R1 cancel to this R1, and hence 365 upon T2 is equal to 1 upon 1 upon 2 to the power 3 by 2. That implies 365 by T2 is equal to 2 to the power 3 by 2. Okay. It can be also written as 2 root 2. Okay. That implies T2 into 2 root 2 is equal to 365. And hence T2 is equal to 365 upon 2 root 2 days. After solving it will come 129 days approx. This is our answer. Okay. Third one is here. The average distance of the sun from a planet is 9 times in comparison to its distance from the earth. In how many years that planet will complete one revolution around the sun? This question is also based on the Kepler's third law of planetary motion. Okay, it is so easy, so simple. Look here. From Kepler's law, okay, T square varieties R cube. It can be also written as T1 upon T2 is equal to R1 upon R2 to the power 3 by 2. Okay. According to question, T1 is equal to 1 year and T2 is equal to what? The average distance of the sun from a planet is 9 times incomplete to its distance from the earth. Our earth complete one revolution in 1 year. So T1 is equal to 1 year, and according to question, R2 is equal to 9 into R1. Okay, since R1 is equal to R2 is equal to 9 into R1 and T1 is equal to 1 year. This is according to your question. This R1 cancelled this R1. That implies 1 upon T2 is equal to 1 upon 9 to the power 3 by 2. Okay. That implies 1 upon T2 is equal to 1 upon 3 to the power 2 upon 3 upon 2 to the power 3 upon 2. These two cancel to these two, and therefore 1 by T2 is equal to 1 by 3 to the power 3. That implies 1 by T2 is equal to 1 by 27. This indicates that T2 is equal to 27 years. This is our answer. That means the planet takes 27 years to complete one rotation if the distance will be increased from 9 times from the average distance of the earth to the sun. Okay. Now in next video I will explain some hot numerical related to it. Till, thank you. Have a nice day.